Hey guys, welcome to SciMath. Today in this video, we are going to be discussing the most important foundational topic to Algebra 1. This topic, in my opinion, is very essential to understanding every other topic in algebra. It comes in handy all the time, whether it be the SAT, your typical math classes, or even AP classes. Every other topic sort of builds off of this topic, and the topic here is slope. So, firstly, one would associate the definition of slope with a mountain, where it is often said that the slope of the mountain is very steep. It's very hard to climb. That's what most people would say if it's very steep. So, this is what we're referring to when we say the slope of a mountain. But the same applies to graphs as well. And so, what I mean by that is, first, before introducing slope and everything, we first need to introduce what x and y coordinates are on a graph. So, first of all, here's how a graph looks like. So, this vertical line here is the y-axis. This horizontal line here is the x-axis. So, the coordinate form of a point is x, comma, y. So, if I wanted to plot the point, let's say, I don't know, like 2 and 1, pretty basic. So, what happens is, as you can notice, these are both representing x and y values, and they are both positive. So, what you can remember is that, so on this graph here, this is the origin. We always start from the origin, which is 0, 0, which means that the x and y values at this point is 0, 0. Now, to plot the point 2, 1, we will have to go 2 to the right because it's a positive number. So all the positive numbers on the x-axis are to the right. So all the positive numbers are here. The negative numbers are here for the x values. The y values here are positive on top, and then the bottom half is negative numbers. And then one more thing about graphs in general is that there are 4 quadrants. So this is quadrant 1, this is quadrant 2, this is quadrant 3, and this last one here is quadrant 4. Just to remember, it goes in this order like a square. So sometimes questions might ask you like where in which quadrant is the point located, and so on and so forth, and it'll even complicate it sometimes. So these are the 4 quadrants: 1, 2, 3, 4. So just remember. But that's not like, that is an important part, but the other part that I want to show you is, just keep in mind that this is positive, negative, and negative. So to plot the point 2 at comma 1, we will go first. We're starting at the origin. Then the 2 is our x value, so we'll look at the x-axis, and the x-axis has this side as the positive number. So we go 1, 2. So this is 2. Right, this is 2. Let's say this is 2. And then from there, we go up 1 because we want a positive y value. So we go up 1. So that is our point right there, 2, comma 1. Now, I can plot another point and show it to you. So, for example, if this was just negative 2 instead of 2, comma 1, all we had to do really was just start at the origin again. So it's a separate point this time. We start at the origin, we go negative 1, negative 2 to the left because all the negative numbers are here. And then for the y, it's still positive, so we still go up. And so there is our point, negative 2, comma 1. So that's how you plot points on a graph. Now, for the slope, it's just about the slope. The basic definition of slope is rise over run. And so it's rise over run. I have it right here. So for example, if I have a slope of, first of all, let me just take all of this off. Okay. So if I have a slope of, let's say, 2 right here, here it is, a slope of 2. So that's essentially 2 over 1 in rise over run form. So if I were to plot the slope, so slope would be essentially a line on the graph. It would look something like this, or it could look something like this, which we'll talk more about later. But for now, let's focus on this slope. So it's a positive 2. And I said the definition is rise over run. So what we're gonna do is we're gonna start from the origin. We're gonna go up by 2 because it's a rise, and it's essentially y over x. This is equal to y over x. So y is our up and down rise, and run is our x and y because we're running from left to right. No one really runs up or down. We always run left to right, and rise is going up and down. So we have a slope of 2. So we rise 2, we go up to 1, 2. There's our 2, and then from there we run 1 to the right because it's positive. So there's our first point. Now, to make this look like a slope, we just need to move we need to do the same thing from that point onward. So we go 1, 2, and over 1. So the next point would be somewhere, it would be 4 and 2. So 4 comma positive 2. Then we keep going like that. We go 1, 2, and 1 over to the 1 over to the right. So that would be 6 comma 3. So on and so forth. Now you can see how this kind of looks like it's forming a line here, right? So that's essentially our slope. So this whole line, if you were to take any point on the graph, like for example 4, 2, and 2 comma 1, and see the difference, it would come out to be 2. But there is a formula to find the slope. It's not that complicated. It's essentially the difference between the two values, but there is a formula, which we'll talk more about later. But this is how the slope looks like. Now, from here to go on to the negative side, because the slope looks incomplete. So let me just tell you. One thing is that slopes are infinite. So they never ever stop. They always go in each direction. So to go in each direction, we needed to take it to the other side as well. So again, you would start with the origin. This time you would just go down 2 because we're still, the first value is rise, right? So we would go down this time instead of going. You wouldn't make a careful mistake, like a mistake not to make and be careful of, is not to start with the run and then the rise, because that might be confusing and people might start with the run and then go down to the rise, but you always start with the rise. So from the origin, now we go down because rise is still up or down and run is still left or right. So this time we go down 2, so we're at negative 2, and then we go 1 to the left. So negative 1 here. So this is our point. And then so on and so forth like that. We go down 2, 1 over. So we're at negative 4, negative 2. Then we do the same thing and we're at negative 6, negative 3. Same point as that, just with the negative sign. And then you can just connect dots. You can just connect the dots and there you have it, a slope. Your slope is 2. And then to show that your slope is infinite, you put these arrows around on both sides of the line. So that's essentially what slope is. Now, there are other ways of representing slope and many other things, which we haven't talked about, but we will. So, the first most common way is the slope-intercept form. Now, this is the way that most math classes use slope-intercept form, and this is the equation for it. Now, if you look at this, you might be wondering what all these variables mean, and let me explain. So this y value here is just your xy coordinate. So for example, let's continue with the example of 2 comma 1. So essentially what slope is trying to tell you that when you input an x value, the output that you get is your y value. So in this equation, or in this form, slope-intercept form, when you plug in a value of 2 for x, your output is supposed to be 1 with your slope and your y-intercept. Now, I kind of gave it away, but yes, this y value is the y value of your coordinate. M is the slope here. So M is your slope. So M is your... Here, M is your slope. Here, so M is your slope. Let me just shift over a bit here. So M is your slope. The x here is just your normal x value. And then this b right here is your y-intercept. So let me just... This here, this y value, this b value is your y-intercept. Now you may be wondering what that means. So what that means is, if I say y-intercept, that means that the x value at that point is 0. And same goes for the x-intercept, because there is an x-intercept. And if I say x-intercept, that means that the y value there is 0. So that's essentially the difference between it. So the easy way to remember it is if I ask you for the y-intercept, immediately in your head it should pop off that x, the other one, is 0. And if I say x-intercept, the other one is 0. So that should automatically pop up with practice and time. So that's what the slope-intercept form means. Now, if I were to ask you what is the slope of an equation, so let me write down an equation here as an example to show what it would look like. So this would be y is equal to 2x plus, let's say 3. So now, in this example, you notice how the y and x values are just variables, because you can plug and chug different numbers in for the x and y points and check if this equation still holds true. And so here, the 2 means, the 2 is your slope. So I'm just going off of this example that we did here with the slope of 2, this line here. But your slope is going to be 2, and this 3 is your y-intercept. That means that when y value is 3, the x value is 0. So it's essentially going to be 0 and comma 3. Now, if you don't believe me and you think this is just not true and there's something wrong with it, we can check it by putting it into the equation. Now, if I were to plug in a 0 for the x, 2 times 0 plus 3, that's what you would solve for, and you would get your y value. So this would come out to 2 times 0 is 0, and 0 plus 3 is 3. So that is your y value. So that comes out to be 3. So 3 is your y value. So as you can see, this is true. This point holds true with this equation. And it is a y-intercept because the x value at that point is 0. So that's what the slope-intercept form can tell you. That's all it can essentially tell you that there is. Now, if you wanted to find the x-intercept, and there is no simple formula, or in this case, the b value is the y-intercept, there's no such thing with the x value. But what you can do is, like I said, the x-intercept is when the y value is 0. So all you have to do is set the equation equal to 0, because the y value is 0, and so that would just be 2x plus 3. One second. This would just be 2x plus 3 equals 0. So all you have to do is set it equal to 0, and then you just subtract 3. So that would just give you negative 3, right? So then we have 2x equals negative 3. Now all you have to do is divide by 2. So what this is saying is that the x value is negative 3 over 2, or negative 1.5. So now that that's out of the way, so that what that means is, just to clear that up a bit if there's confusion, what that means is the x-intercept is at negative 3 over 2, comma 0. Now notice how the y value is y here, so that's just what it means. So we found the y-intercept in this case. That's how you can find, so not the y-intercept, the x-intercept. That's how you can find the x-intercept with this form. And so let's just recap real fast. So with the slope-intercept form, you can essentially find the slope. That's very easy to spot. It's always a value next to the x. And then the b value is just your y-intercept. That means that the x value is 0. And then for x-intercept, you just have to set the equation equal to 0 and solve for x. Now, if you notice here, there's this different form that I've written down here, and I'll bring it here so that we can start on a new kind of page. But this is the standard form. This is another way of representing slope, and it's not that common. It's not as commonly used, but it is still something that is, for example, tested on the SAT and all those kind of things. So it's very, very important to know how this form works and what each variable represents. So in this case, A, B, and C, they're all integers. They're just all representing integers. Now, one way, if students find this hard, often the standard form, what they do is they just solve for it and like manipulate the variables around and turn it into a y is equal to mx plus b format. You can do that because if you notice, the c value here is essentially the b value in the y is equal to mx plus b form. It's the y-intercept. So what you would do is you would subtract the minus ax, and you would get by is equal to negative ax plus c, and then you would just divide it by b, and you would get y is equal to negative a over b x plus c, right? And or whatever value you have in there. If you have a negative value for c, it would just be minus c, but you get the point. That's how it would look like. It would look like, let me just write it out, like the final form. So it will look like y is equal to negative a, because we subtracted the negative a over negative ax over b, and then there's your x and plus c. So your c is your b value, negative a over b is your slope, and x is just x, and y is obviously just y. Now, but there's another shortcut, another way that you don't have to sit and shift everything around to get it into this form, and that is you can find everything you need with the standard form. That's what I kind of like about the standard form, is that you can find it with very simple formulas. And so to find the slope, all you have to do is plug the values into the form negative a over b. So this is negative a over b, and with this form, you can find the slope. And I apologize for my handwriting, but you can find the slope. Now, if you can find the slope with minus a over b, the good thing about the standard form is you can find the y-intercept and the x-intercept with simple formulas. It's not that hard. You don't even have to shift it around. So for the x-intercept, all you have to do is do c over a, and you will get your x-intercept. So that's your x-intercept. That's a very easy way. You don't have to like plug first, like shift the whole thing into y is equal to mx plus b, and then set the equation equal to 0 and solve for it. That's a very, very long process. This is way, way more simpler. Then to find your y-intercept, lastly, that is just c over b. So just do c over b, and you get your what's it called? You get your y-intercept. Now, if you want to see this in action, we can do an example and kind of show how that works. So, let's say I do 2x plus 3y equals 6. So now you'll notice how this is in standard form right now, and it doesn't look like that y is equal to mx plus b at all. Now, if you did want to turn this into a y is equal to mx plus b form, you can do it by subtracting the negative 2x to the other side, then dividing everything by 3, but that would, again, take way too long. So now, for the slope, let's do it. Minus a over b, so this is your a, this 3 is your b, and the 6 is your c. So minus a over b, so that would be negative. Now, a is just 2, so negative 2 over 3 is your slope. And then for your x-intercept, it's c over a, so we would just do 6 over 2. That is just 3. So our x-intercept is at 3, 0. Now, for the y-intercept, I'll just do it over here, is c over b. So we would just do 6 over 3. And that is just 2. So our y-intercept is at 0, 2. Now, if you did want to check this all and see if you're right, you could either do it on Desmos and plug in just the standard form equation, and Desmos will tell you where to look for it. Like you can look on the graph, or you can just turn it into a y is equal to mx plus b. But again, this way is way much easier. So I would definitely recommend doing this to save time on tests and quizzes. So that's essentially those two ways. Now, if we were to talk about, so there's two different types of slopes. One is your positive slope. So on a graph, it would mean a positive going up like this, whereas a negative graph, a negative slope, would look something like this, be going down. So just always remember that an easy way to remember this is essentially that a positive slope is when you're climbing up the mountain, and a negative slope is when you're climbing down the mountain. That's how those two slopes would look like on a graph. Now, another trick that I wanted to share was that when dealing with graphs, often one trick that's not a trick, but it's like a fact that's applied to questions is that the slope of a line, for example, let's say that the slope of 2 that we had here. So this has the slope of 2. Now, we can also make right angles with another slope. So that just like if we were to make a right angle with another slope, that means that that line is perpendicular to the slope that we have here of 2. So what that means is that the line would cut this slope of 2 that we have here and kind of make right angles, as you can see here. I'm kind of drawing it out, but that would mean that this negative slope line is perpendicular to the slope of 2 that we have here. Now, perpendicular slopes always have, like, the slope of this negative slope should be multiplied with 2 and come out to be -1. So that number here is essentially 2. You would do 2 times -1/2. So when you do that, the 2's cancel out and you're just left with -1. You're left with -1, and that's how you find the slope of a perpendicular line. So for example, if this was a question and I said that this slope over here, this line over here has a slope of 2 now, and there's this other line that's perpendicular to it. So what is the slope of this line that's cutting it and making it perpendicular, that is perpendicular to this line? So essentially what you would do is think of a number that multiplies with the slope of 2 and comes out to be -1. That's always the case with these perpendicular ones. So that's all I wanted to share in this video, and I hope this was helpful in understanding all about slopes, because this concept is so very important when it comes to just understanding anything about algebra and anything, so on and so forth, because it just builds on off of this. And so it's very important that this foundation is pretty clear, and these were just like the basic things that are needed to build off of it. And so always remember to stay curious and keep learning. Thanks for watching.